Hello, I am Mrs. Ruma Dhanvate from Aryan College of Arts, Commerce and Science. In today's video lecture, we shall see Unit number 5, Study of Design Patterns. GOF, that is Gang of Four. These are the four authors of the book Design Patterns, Elements of Reusable Object-Oriented Software. They have been working on C++ and Java for a lot of years, and they have found out the patterns which are categorized into three types of patterns: creational pattern, structural pattern, and behavioral pattern. Now the creational design patterns include abstract factory, builder, factory method, prototype, and singleton method. The structural design patterns include adapter, bridge, composite, decorator, facade, flyweight, proxy. The behavior design patterns include even 11 design patterns which have chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor method. In the creational pattern, we shall see three types of patterns: factory pattern, singleton pattern, and abstract factory. The first pattern is the factory pattern. It is one of the most used design patterns in Java. This type of design pattern comes under creational pattern, as this pattern provides one of the best ways to create an object. In this pattern, we create object without exposing the creation logic to the client and refer to newly created object using a common interface. Now you can go through the diagram here. We are going to create a shape interface and concrete classes implementing the shape interface. A factory class shape factory is defined as a next step. Factory pattern demo. Our demo class will use shape factory to get a shape object. It will pass information like circle, rectangle, or square to shape factory to get the type of object it needs. Next is the singleton pattern. Singleton pattern is the simplest design patterns in Java. This type of design pattern comes under the creational pattern and provides one of the best ways to create an object. This pattern involves a single class which is responsible to create an object while making sure that only single object gets created. This class provides a way to access its only object which can be accessed directly without need to instantiate the object of the class. You can go through the diagram and see that we are going to create a single object class. Single object class have its constructor as private and have a static instance of itself. Single object class provides a static method to get its static instance to outside world. Singleton pattern demo, our demo class, will use single object class to get a single object. Next creational pattern is abstract factory pattern. Abstract factory pattern works around a super factory which creates other factories. This factory is also called as factory of factories. In abstract factory pattern, an interface is responsible for creating a factory of related objects without explicitly specifying their classes. Each generated factory can give the objects as per the factory pattern. We create a shape interface and concrete classes implementing it. We create an abstract factory class, abstract factory, as the next step. Factory class shape factory is defined, which extends abstract factory. A factory creator or generator class factory producer is created. Abstract factory pattern demo. Our demo class uses factory producer to get an abstract factory object. It will pass information circle, rectangle, or square for shape to abstract factory to get the type of object it needs. Now we shall see the structural patterns: adapter, decorator, and facade. The first is the adapter pattern. Adapter pattern works as a bridge between two incompatible interfaces. This type of design pattern comes under structural pattern as this pattern combines the capability of two independent interfaces. This pattern involves a single class which is responsible to join functionalities of independent or incompatible interfaces. We use the adapter pattern via following example in which an audio player device can play MP3 files only and wants to use an advanced audio player capable of playing VLC and MP4 files. We have a media player interface and a concrete class. Audio player implementing the media player interface. Audio player can play MP3 format audio by default. We are having another interface, advanced media player and concrete classes implementing the advanced media player interface. These classes can play VLC and MP4 format files. We want to make audio player to play other formats as well. To attain this, we have created an adapter class media adapter which implements the media player interface and uses advanced media player objects to play the required format. Audio player uses the adapter class media adapter, passing it the desired audio type without knowing the actual class which can play the desired format. Adapter pattern demo or demo class will use audio player class to play various formats. Here is the diagram for the adapter pattern. You can see the interface here, advanced media player and the concrete classes VLC player and MP4 player. Adapter pattern demo, here you have a main from where your execution starts. Next is the decorator pattern. Decorator pattern allows a user to add new functionality to an existing object without altering its structure. This type of design pattern comes under structural pattern as this pattern acts as a wrapper to existing class. This pattern creates a decorator class which wraps the original class and provides additional functionality, keeping class methods signature intact. We use the decorator pattern via the following example in which we decorate a shape with some color without altering the shape class. We create a shape interface and concrete classes implementing the shape interface. We will then create an abstract decorator class, shape decorator, implementing the shape interface and having the shape object as its instance variable. Red shape decorator is concrete class implementing the shape decorator. Decorator pattern demo is the demo class which uses the red shape decorator to decorate the shape objects. Next is the facet pattern. Facet pattern hides the complexities of the system and provides an interface to the client using which the client can access the system. This type of design pattern comes under structural pattern as this pattern adds an interface to existing system to hide its complexities. This pattern involves a single class which provides simplified methods required by client and delegates calls to methods of existing system classes. We create a shape interface and concrete classes implementing the shape interface. A facet class ShapeMaker is defined as a next step. ShapeMaker class uses the concrete classes to delegate user calls to these classes. Facet pattern demo is the demo class which will use ShapeMaker class to show the results. The third type of design patterns are the behavioral pattern, which include the 5 types of patterns: command, iterator, observer, state, and strategy. The first is the command pattern. Command pattern is a data-driven design pattern and falls under behavioral pattern category. A request is wrapped under an object as command and passed to invoker object. Invoker object looks for the appropriate object which can handle this command and passes the command to the corresponding object which executes the command. We have created an interface order which is acting as a command. We have created a stock class which acts as a request. We have concrete command classes BuyStock and SellStock implementing order interface which will do actual command processing. A class broker is created which acts as an invoker object. It can take and place orders. Broker object uses command pattern to identify which object will execute which command based on the type of command. Command pattern demo is a demo class which will use broker class to demonstrate command pattern. Iterator pattern. It is very commonly used design pattern in Java and .NET programming environment. This pattern is used to get a way to access the elements of a collection object in sequential manner without any need to know its underlying representation. We are going to create an iterator interface which narrates navigation method and a container interface which returns the iterator. Concrete classes implementing the container interface will be responsible to implement iterator interface and use it. Iterator pattern demo is a demo class which will use name repository, a concrete class implementation, to print the names stored as a collection in names repository. Observer pattern. It is used when there is one-to-many relationship between objects, such as if one object is modified, its dependent objects are to be notified automatically. Observer pattern uses three actor classes: subject, observer, and client. Subject is an object having methods to attach and detach observers to a client object. We have created an abstract class observer and a concrete class subject that is extending class observer. Observer pattern demo is the demo class which we will use subject and concrete class object to show observer pattern in action. State pattern. In state pattern, a class behavior changes based on its state. This type of design pattern comes under behavior pattern. In state pattern, we create objects which represent various states and context objects whose behavior varies as its state object changes. We are going to create a state interface defining an action and concrete state classes implementing the state interface. Context is a class which carries a state. State pattern demo or demo class will use context and state objects to demonstrate change in context behavior based on type of state it is in. Strategy pattern. In strategy pattern, a class behavior or its algorithm can be changed at runtime. We create objects which represent various strategies and a context object whose behavior varies as per its strategy object. The strategy object changes the executing algorithm of the context object. We are going to create a strategy interface defining an action and concrete strategy classes implementing the strategy interface. Context is a class which uses a strategy. Strategy pattern demo or demo class will use context and strategy objects to demonstrate change in context behavior based on strategy it deploys or uses. So these were the three types of design patterns, and these are the references. Thank you.